In this video, we look at mutually exclusive and non-mutually exclusive events. So two events are considered mutually exclusive if they have absolutely nothing in common. So these would be two sets that are disjoint. So you can think of making a left-hand turn and making a right-hand turn if you were driving. You can't make both at the same time. So these two events would be mutually exclusive. There's no overlap between making a left-hand turn and a right-hand turn at the same time. Now, two non-mutually exclusive events have something in common. So for example, if I were to look at making a left turn while driving and whistling, I could whistle while I'm driving, or I could whistle while I'm not driving. And I can certainly whistle while I'm making a left-hand turn. Those two events would be non-mutually exclusive, so there would be some overlap. So I could make a left-hand turn while I was whistling, or whistle while I was making a left-hand turn. So in order to look at probabilities of mutually exclusive and non-mutually exclusive events, we have to figure out the number of elements here. And for doing that, we need to look at the principle of inclusion, and exclusion. So this n here just represents the number of elements in A or B. So this little u here stands for a union, or is a union symbol. It means or. So this is the or symbol. So this is the number of elements in A or B is equal to the number of elements in A plus the number of elements in B minus their overlap. So in the example we looked at up here, I can't just take the number of elements here and add it to the number of elements in W, because then I would be adding the elements in the middle twice. So that's why we have to subtract the elements in A and B. So this symbol here just means the intersection. It means and. It's what they share. So the common sort of word here would be and. So A and B, or A intersection B. And similarly here, the union is A or B. So the key word here being or. So in words, that just means that the number of elements in A or B, is equal to the number of elements in A plus the number of elements in B, and then we subtract the overlap since we've counted it twice. Let's look at an example. So here we go. At the start of flu season, a doctor examines 50 patients over 2 days. 30 have a headache, 24 have a cold, 12 have neither. Some patients have both. The question here is, what is the probability that a random patient has both symptoms? Pardon me. So we're going to start with a Venn diagram, and in that Venn diagram, we should probably state here. Well, here's our Venn diagram. We have we have a headache, so we'll let this be H, and we have cold. This can be C, and there's going to be some overlap, so I've drawn some overlap in here. We know that there are 12 people who have neither. So the universal set here is a set of all patients that the doctor saw. So we'll just draw a box around all of this so that we have a spot to indicate neither. So that's going to happen right here. And we know that 12 have neither. So we'll just put a 12 outside here. Now we want to find the probability that a patient has both symptoms. So the both symptoms part is this section right here. Let me just change the pen color here. Right in the middle here. This section right in here. So we need to figure out what that total is. Well, we can do that using the principle of inclusion and exclusion. So the number of people, in this case, who have both a headache and a cold, we need the number of people who have a headache, the number of people who have a cold, and that's going to help us find the number of people who have a headache and a cold. So let's look at the number of people with a headache or a cold. So the number of people with a headache or a cold, and we should specify here, let's say that A is the headache. So A is a headache, and B is a cold. So B is a cold. So the number of people with a headache or cold then, we had 50 people in total, 12 have neither. So we can subtract those two and get a total of 38. So we now know that there are 38 people who have one symptom or the other. And now we can kind of use the principle of inclusion and exclusion. So this number of people with A or B, so with a head cold or a cold or a headache, is 38. So we can substitute that into the equation, and we get 38 equals the NA comes from over here. So A is the number of people with a headache, which is right here, is 30. We have to add in the number of people who have a cold. Up over here is 24. And then we subtract the number of people who have both. We don't know that number, but that's what we're going to work to find. And now we can just solve this equation. 30 plus 24 is 54. And we know that there are 38 people with both. So we can solve the equation here, subtract 54 from both sides, and we get negative 16 equals negative negative here for the number of people in A and B. To solve this, divide both sides by -1, and we get the number of people in A and B, is equal to 16. So that tells us that the overlap that we were looking for, this little bit here, is 16. Now we can actually find the other values in the Venn diagram. We weren't asked to do so, but we certainly could just by doing a little bit of arithmetic. So let's just do that. We know that the number of patients who have a headache is 30. So we know that in this part of the Venn diagram we need a total of 30. 30 minus 16 gives us 14. So we can drop that right in the diagram. And then we can also look at the number of people who have a cold. So there were 24 people in total. 24 minus the 16 that are already there gives us a total of 8. Again, we didn't have to do that for this question. Remember, the question asked, what is the probability that a patient has both symptoms? Well, both symptoms right here in the center of the diagram, that overlap. So the probability then is just the number of ways that that can happen. So the probability of having a headache and a cold is equal to the number of ways we can have a headache and a cold divided by the total number of people in this case, I guess. So the number of the number of people who have a headache and a cold is 16. The total number of people was 50. And now we have this fraction that we can reduce to 8 over 25. So that's how we can use probabilities to find values using mutually exclusive and non-mutually exclusive event. It was an event that was non-mutually exclusive. The exclusive events are fairly straightforward because the overlap, this part right here, is just equal to 0, so that becomes really easy.